Hi guys, so this video is due on Thursday. This is review for your exam. So you really want to make sure you get this done before your exam on Friday. Alright, and this will also help you with the review in class. So the two important formulas we learned this unit are y equals ab to the x and a equals p, 1 plus or minus r raised to the t power. In both of these, we have a y-intercept, or some starting value, and we also have a multiplier. The one on the right, though, gets their multiplier slightly different by using a rate. And that is given to you as a percentage, but remember we need to convert it to a decimal. And lastly, our exponents. So when do I use them? I use the one on the left when I see a graph or a table, or I'm just given two givens. I use the one on the right when I see percentages or problems with money or interest. Or I'm given three givens. Okay, so let's look at modeling exponentials question. A computer valued at $6,500 depreciates at the rate of 14.3% per year. So what function am I going to use to model that? I see a rate as a percentage, so that indicates that I'm going to use the A equals formula. And it depreciates, which means it's going to be a decay. So I'm going to use the minus. So my starting value, 1 minus, and then this as a decimal would be 143. And per year, I don't know. Second part says find the value after 3 years. So that is when I'm going to substitute. And I'm going to substitute in for 3. Let me grab my calculator. And I'm going to type this in. And remember, I'm talking about money. So I'm going to round my final answer, 4,091.25. Okay, that's the value of the computer after 3 years. All right, another thing we did that will be on your test is graphing exponential functions. Remember, this is our y-intercept. So that's going to go with the 0, and this is our multiplier. So that tells me how this is going to change. So 3 times 2 is 6. 6 times 2 is 12. And then I'm going to go backwards. And I go backwards by doing the inverse, which in this case, the inverse is dividing. Alright, so negative 2.75, negative 1. 1.5 is 0, 3, 1, 6. Make sure to extend to the edges of your graph. Alright, exponential or not? What type of model, linear or exponential, would be best for the situation? Explain why. I'm going to start by counting. So there's 6 there. 10. And 14. So to go from here to here, I add 4. Here to here, I add 4. This is a linear function. And y. What do we call that? actually going to re-go over my answer. Because it has a constant rate of change, what's it? So I'm changing it to linear would be best because the tiles grow by a constant rate of change instead of it has. All right, last question, interpreting exponentials. Milton has money invested in a stock portfolio. The value of his portfolio can be modeled by this equation. X is the number of years since he made his investment. Which statement describes the rate of change of his portfolio? So remember, I look at my multiplier, which is 0.78. I'm going to convert that to a percentage, which is 78%. And I want to know how much it's changing from the whole. And we're figuring out what is it changing. 100. So that equals 22%. Now I see two answers with 22%, so I need to figure out if it's increasing or decreasing. And I know it is decreasing because 0.78 was less than 1. So that means it must be choice number 2. All right, use this to help you study. Use this in class on Thursday. And remember, there is an assessment on Friday.